Hermann Hesse's novel The Glass Bead Game describes a world of pure order, an intellectual game in which mathematics, music, and philosophy are woven into a harmonious, almost spiritual pattern. The players combine abstract symbols and formulas not to achieve anything practical, but to create a self-contained system of knowledge. But what if our entire scientific worldview is also such a glass bead game? A sophisticated, internally consistent structure that nevertheless captures only a fragment of reality? This question is not merely literary. Modern science has delved into increasingly abstract theories, particularly in particle physics, where billions are invested to decipher subatomic structures. The Large Hadron Collider has confirmed the Higgs boson, relativity theory has redefined the framework of space and time, and quantum mechanics describes a universe that seems to exist beyond classical logic. And yet, there are phenomena that do not fit neatly into this highly precise schema. UAPs, unidentified anomalous phenomena, whose origin and behavior defy our current understanding of physics. PSI phenomena, where people report intuitive or precognitive experiences that are difficult to explain within known natural laws. Extraordinary states of consciousness, induced through meditation or near-death experiences, which include accounts of interdimensional encounters or an expanded sense of reality. The critical question is, are our scientific models still tracking reality, or have we become lost in a closed theoretical system that obscures the immediacy of existence? Science between theory formation and experiential reality. The idea that the visible world is merely a shadow of a deeper order is ancient. Plato spoke of the world of ideas, a sphere of pure, immutable forms, of which our perceptible reality is merely a faint reflection. Modern philosophy of science encounters similar limitations. Gödel's incompleteness theorems demonstrate that within any formal system, there are truths that are valid but unprovable within the system itself. The double-slit experiment in quantum mechanics suggests that reality changes depending on whether it is observed or not. Quantum entanglement reveals that particles can remain instantaneously connected over vast distances, without any classical interaction taking place. These insights suggest an unsettling possibility. What if our scientific worldview is merely an approximation of a much deeper reality, one that our conventional methods are not yet capable of grasping? This raises an alternative perspective. Are phenomena like PSI or UAPs not anomalies but clues to a deeper order? An order we have overlooked because our scientific instruments are not designed to detect it? The limits of classical research, a glass bead game of particle physics? Modern science has undoubtedly produced groundbreaking discoveries. It has deepened our understanding of natural laws, enabled new technologies, and revolutionized our worldview. Yet, a paradoxical trend emerges: the more precise our models become, the more unresolved mysteries appear. A particularly striking example is particle physics. The Large Hadron Collider has achieved significant breakthroughs, yet fundamental questions remain unanswered. Dark matter and dark energy, 95% of the universe consists of something we do not understand. Quantum gravity, the unification of quantum mechanics and relativity theory, remains incomplete. The problem of consciousness: how does subjective experience arise, and could it be more than a mere epiphenomenon of neural processes? At the same time, certain phenomena are dismissed by classical science because they do not fit the established paradigm: UAPs, PSI phenomena, and expanded states of consciousness. But could these very phenomena be indicators of a greater reality? Is it possible that our scientific worldview is so fixated on measurability and mathematical elegance that it excludes other layers of reality from consideration altogether? 3 alternative explanations: simulation, consciousness, emergent reality. If our universe is indeed more than what classical science describes, several models come into play. 3 possible scenarios.
The universe as a simulation.
The simulation hypothesis, as formulated by Nick Bostrom, suggests that an advanced civilization could create a reality indistinguishable from a real one. If this is true, then anomalies such as UAPs or PSI effects could be glitches or unintended errors in the simulation. A possible clue lies in the fact that the laws of nature often appear too perfect, as if they were programmed. B. Consciousness as the fundamental reality. Philosopher Bernardo Kastrup argues that the universe is not composed of matter but of consciousness. The physical world would then be a kind of collective perception of a universal mind. This could explain why phenomena like telepathy or precognitive perception are considered natural in some cultures while being dismissed in Western scientific models. If consciousness is fundamental, reality itself could change through mental processes, a radical departure from the materialist worldview. C. The laws of nature as emergent properties of a deeper order. A middle ground between the previous two models is the idea that our known laws of nature are merely emergent structures of a deeper reality. This perspective could interpret UAPs or PSI phenomena as effects of interdimensional interactions. Instead of a binary real or not real approach, this could lead to a scale-dependent physics, where reality behaves differently depending on the level of observation. From paradigm shift to integrative science. Whether we consider the simulation hypothesis, the consciousness model, or the concept of emergent reality, all of these approaches share one key idea: they require an open, interdisciplinary research model. The history of science shows that every paradigm shift began when existing models were no longer sufficient. The Copernican revolution, relativity theory, and quantum mechanics, all these developments were once considered radical or even heretical. Are we standing at a similar threshold today? Science at a crossroads, an interdisciplinary approach. If our current scientific worldview is merely an approximation of a greater reality, the question arises: how can we systematically expand our understanding? The key lies in integrative science, which does not rely solely on classical empirical methods but also develops new research approaches and measurement techniques to investigate previously inaccessible phenomena. A. Physics, neuroscience, and consciousness research as a joint effort. Instead of viewing consciousness as a mere byproduct of brain activity, research could explore whether it actively interacts with physical processes. Existing studies already suggest that meditation and altered states of consciousness produce measurable physiological and neurological effects. Emerging fields such as quantum biology indicate that quantum mechanical processes may play a role in biological systems, hinting at a potential fundamental link between consciousness and reality. B. New measurement methods for subtle phenomena. Existing measuring instruments are based on classical physical principles. But what if there are previously undetectable information fields or interactions? Quantum-based sensors could be developed to detect subtle, non-local phenomena. Instead of merely measuring physical correlations, science could deliberately study nonlinear, emergent processes. C. Consciousness-based experiments. If consciousness actively shapes reality, experimental setups must be redesigned. Precognition studies: are there reproducible indications that humans can perceive future events? Quantum experiments with mental intention: can observation or intention influence the state of a quantum mechanical system? Comparative studies of consciousness states: what measurable differences exist between everyday consciousness and extraordinary perceptual states? Societal and philosophical implications: a new worldview? If these new perspectives prove to be valid, they would not only have scientific consequences but also profound societal and philosophical implications. A. A new understanding of humanity. The idea that consciousness is a fundamental part of reality would radically alter our self-image as human beings. Instead of seeing ourselves as biologically determined entities, we might recognize that our mind is not passive but actively interacts with reality. B. Medicine and psychology as key disciplines. If consciousness is more than just neural activity, medicine might focus more on the interaction between mind and body. Meditation, hypnosis, and alternative healing methods could be re-evaluated as serious scientific research fields.
C. Education and interdisciplinary research.
Scientific education could be restructured to encourage thinking beyond disciplinary boundaries. The divide between hard natural sciences and soft humanities could be replaced by a holistic research model. The big question: are we ready for a paradigm shift? Past scientific revolutions have shown that the greatest obstacle to new insights is often not a lack of evidence, but the limitations of our own thinking. Copernicus' heliocentric model was opposed for centuries. Quantum mechanics was initially dismissed as absurd before becoming the foundation of modern physics. Could phenomena like PSI, UAPs, or a consciousness-based reality represent the next major wave of scientific discovery? The future of science might lie not only in exploring the measurable but also in expanding the limits of what can be perceived. The glass bead game is a symbol of knowledge and its limits. Looking back at the core ideas of this essay, a recurring pattern emerges: our knowledge is structured, but possibly incomplete. Modern science has elevated our understanding of the world to an unprecedented level. At the same time, certain phenomena exist outside of classical models: consciousness, UAPs, PSI phenomena. The glass bead game, as described by Hesse, could serve as a metaphor for today's scientific paradigm, a fascinating, internally coherent system, yet possibly not the ultimate truth. The key question is, how can we look beyond this closed system? If our universe is based on deeper principles, whether a consciousness-based reality, a mathematical structure, or a simulation, then we may be standing at a turning point in our understanding. The choice of the pill, illusion or insight? The red pill metaphor from the Matrix comes to mind. The blue pill represents staying within the established, familiar scientific world, a universe of matter, fixed natural laws, and well-defined methodologies. The red pill, however, symbolizes the courage to embrace a new reality, to question the current worldview and develop new methods. Yet, in science, taking the red pill does not mean jumping blindly into speculation. It is not about dogmatically accepting alternative theories, but about asking uncomfortable questions and boldly exploring new intellectual paths. Perhaps our universe truly is a simulation, an interdimensional structure, or a consciousness-based information field. Perhaps it is even far more complex than we can imagine. But one thing is certain. The greatest discoveries often begin where scientists dare to think beyond existing boundaries. A call for new science and open thinking. This essay is not a conclusion but an invitation. An invitation to view science not as a static system, but as a dynamic process. An invitation to expand scientific curiosity beyond the measurable, making room for the unknown. An invitation to question our perception of reality with the awareness that knowledge often emerges in the most unexpected places. Perhaps the glass bead game of modern science is just the beginning, and the real game, which will reveal the true nature of reality, has only just begun. Quo vadis, science and humanity? We are at a crucial moment in the history of thought. Humanity has developed an incredibly complex picture of reality over millennia. But with every step forward, we also realize how incomplete our knowledge still is. On one side, we have the achievements of classical science, relativity, quantum dynamics, biology, technology, all of which have fundamentally transformed our world. On the other side, we encounter border phenomena, inexplicable experiences, and fundamental questions that do not fully fit within existing models. The central question is, how do we deal with this realization? Do we retreat into the familiar, or are we willing to explore new paths? A paradigm shift, an opportunity, not a disruption. New ways of thinking are often perceived as a threat to existing systems. But if we look at the great scientific revolutions of the past, we see a clear pattern. The heliocentric model did not destroy astronomy, it expanded it. Relativity theory did not disprove classical mechanics, it complemented it with a deeper perspective. Quantum physics did not undermine the idea of a calculable world, it revealed that reality is even more fascinating than we once thought. Similarly, the next major step in science may not be an either-or choice, but rather a both-and approach. Classical science remains but is expanded by new dimensions. Consciousness research and alternative models are not rejected but systematically examined. Measurement methods evolve, allowing us to explore phenomena that were previously considered unprovable. We are not at the end of science, we may be standing at its most exciting beginning. The future lies in our curiosity. The question is not whether we should take the red pill or not, because insight is not a sudden leap, but an ongoing process. The science of the future could be defined by the following principles. Openness to new concepts, without dogmatic rejection or blind acceptance. Interdisciplinary collaboration, where physicists, neuroscientists, philosophers, and computer scientists search for answers together. A holistic view of reality, where matter and consciousness are examined as two aspects of a larger whole. Perhaps we are not only on the verge of a scientific but also a mental and cultural evolutionary leap, a new way of thinking that integrates logic and intuition, science and consciousness, experience and measurement. Science has already shown us that the universe is far larger than we ever imagined. Perhaps it is now time to expand our way of thinking as well. The future awaits, and it belongs to those who have the courage to keep asking questions.